Okay, now we have Rajesh Kumar with the embeddings and vector databases, OWASP top 10 LLM risk.
Hello, everyone. I'm Rajesh. This is a QR code to my LinkedIn profile. I'm currently working in the space of AI engineering for Genius Bank. Previously, I have worked for multiple companies like American Express and Zoho Corporation as well. So I've been working in this field for 3 years now in generative AI space. But before that, I've been working in semantic search and machine learning operations as well. So I chose to go with this topic because this is a very interesting space where I think with working with all these companies, this was an essential part of consideration, which is the security for the RAG pipelines. So now, I think after the explosion of LLMs and retrieval-augmented generation, right? So we are seeing an explosion in vector databases and usage of embeddings. So what happens is this has presented brand new surface areas for security vulnerabilities and attackers to exploit. And with respect to embeddings and vector databases, this is especially important because we have to deal with secured sensitive data, user information, which is much more private. And with respect to RAG pipelines, we have a lot of areas that we need to cover, like sending secure information to LLMs. I think when we ingest or retrieve sensitive data from vector databases, how we embed, and what is the embedding that we use. So all these present new security vulnerabilities. And OWASP, that is a non-profit community-driven. It was initially started for web applications, but they have introduced a top 10 vulnerabilities for LLMs, and one of them, which is the number 8, is talks about all the security vulnerabilities and research that has been done up to 2025. I think they previously released on 2023. So that's what I'm going to talk about here. And they've also discussed some of the mitigation strategies, how software engineers building AI solutions can mitigate strategies for securing their data. This is especially important when there are like a lot of guidelines around building data applications, such as I think in Europe they have GDPR, and I think in US we have HIPAA, which is essential to securing health information, private health informations. So I think as you can guess, this is not more of a Python talk, it's more of a data talk. So OWASP, so that is an open source application security project, that's the abbreviation. It initially started for web applications, and it's a non-profit community-driven project. They had initially, some of the interesting highlights about OWASP is they have a history of releasing top 10 security vulnerabilities. They initially released top 10 vulnerabilities for web applications, and they have a lot of tools which they have open sourced for security testing and security verification standards as well. And you can find a lot of interesting guidelines, especially for security engineers. They have a lot of free tools that they can explore to play around. So this is what I'm going to talk about today. I'll just give a brief overview of embeddings and vector databases and RAG pipelines for people who might be new to this. But I'm pretty sure that most of you guys know about it. And I'll talk about the emerging threats as discussed by the OWASP guidelines for 2025. I'll pretty much focus on the vulnerabilities which talks about vector databases and embedding spaces. So, and also I'll also discuss the practical defense techniques that we can use and some of the actionable insights that we can follow while we are building AI applications as software developers. So embeddings, for people who are new to embeddings here, so embeddings are a way, I think machines understand just numbers, right? So, I mean, that's how most of the code also encodes to bits and bytes. So, but in order for semantic understanding, what machine learning models use is a numeric representation which models use to understand the semantic meaning underlying a textual phrase or a sentence or a paragraph, or things like that. And what this enables us to do is, there are algorithms which have been developed to query or match documents, and that is what exactly vector databases utilize to efficiently retrieve and store textual these embeddings from the textual representation, from the text. And I think some of the popular retrieval algorithms that these vector databases use are, I think if you guys Google hierarchical navigable new worlds or like or IVF, so these are some of the common algorithms for retrieval that these vector databases use. And this is a common RAG pipeline which is used in AI solutions or AI products. So like we have a list of documents. So we cannot embed the entire data into the vector databases. So what we do is, there are different chunking strategies that you can use as well. So like you chunk the strategies into either sentences or words or like paragraphs or in a different structure. So you chunk the data and then embed those sentences or paragraphs to embeddings and store those embeddings into the vector databases. So when the user queries, when the user wants to query specific information from the vector database, his query is actually embedded using the same algorithm. So for example, I think a common embedding is text ADA embedding 002, which is OpenAI's embedding model. So we can use these, we have to use the same embedding model which is used in indexing for retrieval as well. And then the vector database uses these algorithms that we mentioned to retrieve similar documents from the vector databases, and we probably do other validations to retrieve only the top chunks to send it to the LLM, and LLM does the generation part where, based on these chunks and the user query, please provide a response. So this is a general RAG mechanism, and the diagram I have referenced from this blog. Yeah, this is the same thing. Yeah. And as I said, right, so these embeddings can contain very sensitive information which can lead to potential leaks or very sensitive information which is very dangerous. And there are a lot of security vulnerabilities that I will be talking about, and these can lead to violations for the GDPR or HIPAA and other regulations from different countries. So it is essential that we consider all these security mechanisms when we are using these databases. So, so some of the threats, I mean, this is not an exhaustive list, of course, but the OWASP top 10, according to their blog, they listed some of the commonly used threats for vector databases, and one of them is embedding inversion. Embedding inversion provides a way for the attackers to reconstruct the original text from embedding representations, which they can use to reconstruct sensitive data or like sensitive data leak. So, so that is a privacy risk, and there are, so this is one attack that we need to be aware for the for safeguarding our vector databases. And some of the ways that attackers use embedding inversion is direct model access attacks. I know, like, I think a lot of enterprise companies, they actually have their own enterprise version of deployed at their own domain with appropriate access controls. But I think a lot of it is also true that a lot of new companies, they probably use open source models as well, which can lead to these attacks. So let's say, like, if a company, in order for testing, has opened up their model, and maybe like an attacker has direct access to their embedding model. So what they can do is they can train a surrogate model, which is the second point, transfer attacks. They can train a surrogate model, which what they can do is they can repeatedly trigger the model to identify its pattern and mimic the version of the embedding space. So facilitating inversion even with direct access. So another technique is black box methods, which requires a small set of embedding text pairs if they are able to retrieve or exploit with a little bit of data. So they can mimic the same functionality of either an open source embedding model or an enterprise embedding model. So which can lead to data leakage. So for example, embedding inversion has been shown to recover PHI data, public healthcare information, which is a direct violation of HIPAA and patient's trust, which is, people working in these domains should be particularly sensitive, careful about using vector stores. And some of the empirical findings are state of the art. There are a lot of new methods, inversion methods that have been used, and some of the latest methods can recover 50 to 80% of the tokens or reconstruct entire sentences from embeddings. So, there are examples where these transfer attacks can be used to exploit sensitive attributes up to 80 to 99% accuracy. And another study says that multilingual models are more vulnerable because some of the defenses that are used for English when training the models often fail in other languages. So with which they exploit predominantly multilingual models. And that also provides vulnerabilities in English as well, so which they can use to like mimic the same meanings in English. So, so for example, even if an attacker is able to identify small portions of embeddings, we are actually exposing large documents which belong to which correlates around these embeddings, which are similar to these embeddings, right? So, so the next technique is vector poisoning. So, this is a very common attack that attackers use. So, basically they don't have to create embeddings. the user prompt, if let's say like if we don't have enough sanitization in the input prompt or like the user queries, so that can be exploited to insert malicious embeddings into the vector databases. So there is a huge impact in with vector poisoning. It can create biases. It can promote specific contents. And for example, in computer use scenarios, so these systems can be exploited to access computers itself, and in often cases in AI engineering pipelines, right? So what companies will do is probably summarize a user information and then send it to the next RAG pipeline, right? So in those cases, and if those information are actually ingested, so basically they just have to, so they just have to like, if that information is actually around the malicious embeddings, so those information are also exposed. So these are the things that I was talking about. So instruction injection, so when the user queries a vector database, so they can often inject commands or like machine commands which can trigger or override safeguards. Context poisoning, so when it can poison other metadatas around the malicious prompts. So for example, retrieval manipulation is a technique where prompters or like attackers use dense keywords, like they say it's urgent, or like they put in a lot of different keywords around the same area. So what this does is every time when we retrieve documents, since that is a dense portion of that vector database, it probably retrieves some malicious content or malicious malicious data that's been ingested from him. So, and this data extraction is the part where I talked about in terms of multi-agent pipelines, right? So if we summarize one information from one pipeline to the other, and if that information is ingested into a vector database that has been already attacked, so it's easier for them to extract sensitive information from around those areas as well. So these are real world incidents where poisoned RAG, so what this research shows is just 5 malicious documents are enough where the vector database contains millions of entries, and that is enough to achieve 90% success rate manipulating LLM outputs. And another study from Anthropic and UK's AI Scientific Institute, so what they say is just 250 poisoned documents can backdoor LLMs. By backdooring LLMs, what I mean is they can use that ingested data to retrieve sensitive information, things like that. So earlier, I mean, this challenges the earlier assumption where, like a large model cannot be poisoned by small documents. That's not true. And Microsoft 365 Copilot exploit is research from Microsoft itself. They found that prompt injection and automatic tool invocation and data exfiltration, so they can using those techniques, they can access sensitive emails from within Microsoft itself. And there has been an incident where Slack AI data exfiltration, where public channels have been exploited to retrieve and exfiltrate private data, because they've been using the same vector databases for both private and public channels. So these are all common incidents. So from what we see, a poisoned vector database, or like when it is ingested with poisoned embeddings, those embeddings act as Trojan horses. They persist there, and like even retraining the model doesn't help. So the second point is they can even bypass domain-specific access controls. So for example, we might have given different access controls for different agents or different APIs, but when it is part of a RAG pipeline or a multi-agent pipeline, right, what happens is it's very common for us to summarize in one specific agent and pass the information to the other, or like have it in a retrieval in a vector database. So it's easier for them to like override. So basically what they are doing is overriding domain-specific access controls and get sensitive information from a different pipeline. So we have to be very aware of these kind of attacks. And the next vulnerability that I wanted to talk about is supply chain. So there are a lot of open source models, especially from Hugging Face, and it's not only about open source models, but also about open source libraries that we are using, right? So, so this presents a new set of challenges that we have to vet through. So, so what happens is when I think there was a research when a malicious model was trained. So I think it's called a GPT-7 6B or something like that. They actually, this is not an attack. What they did is they uploaded a malicious version of the same model. And people thought that it was the same model, but they actually downloaded it from a different source. So it is very important to validate the source of the models. So, and what that malicious, with those malicious model, they were able to bypass security scans when they are uploading to Hugging Face as well. So the way they train these malicious models is they just train a LoRa adapter where with a different set of parameters for the LLMs. They actually, what they do is this. What this does is it resembles predominantly the model which was uploaded by a legitimate source, but sometimes it might exhibit maybe a biased behavior, so some malicious activity when the LoRa adapter is triggered. And model merge and conversion exploits. So model merging is common when people want to adapt a well-performing model. So they merge the parameters of a very well-performing model, and these techniques are being used to create a malicious model as well, which they upload to Hugging Face. And the same thing, model conversioning services is nothing but when we convert models from one format to the other. So for example, a model trained in PyTorch can be converted to a model trained in Keras, sorry, TensorFlow. So with these model conversioning services, they also introduce new vulnerabilities. And this is not particular to the dependencies or the libraries that we use. Is not particular to AI engineering. It's common to software engineering as well. I think I have less time, so I'll probably fasten up. So, and some of the common supply chain impacts are, so from an empirical analysis as early as August 2025, 52 open source, when they researched 52 open source LLM models, 75.8% of these models have vulnerable dependencies in their configuration files, and dependency chains up to 40 layers are very common. So some of the defense strategies that everyone can use to prevent these kind of attacks are data encryption at rest and in transit. So it's very common nowadays for all the vector databases to provide those functionalities natively. So for example, SQL Cipher, MongoDB provide queryable encryption to provide protect embeddings from unauthorized access. In transit, we can use HTTPS or TLS. Those are common secure protocols to use in transit. Homomorphic encryption, when we are doing embedding conversion. So these homomorphic encryption allows us to compute the encrypted data to, it allows us a way to create embeddings with encrypted data. Role-based access controls for inserting, querying, modification, and things like that. And this should also be common where we sanitize the retrieval from embedding and on ingestion as well. But there are also common practices where the user's data is being sanitized for malicious intent, as well as when they are responding, right? So the user should also should not receive any sensitive information, and it should be safe for them as well. So input validation, we have to be careful about contextual summarization so that we don't leak sensitive information. Metadata filtering, which is attach metadata to these embeddings such as source, access level, so that when we are retrieving it, we identify the source of who is querying and provide them with information that there are statistical outlier detection methods, ML-based methods, hybrid methods where you use LLM itself to identify the patterns, whether we have actually retrieved, whether it is true positive or false positive, things like that. So it is essential that when we are training these models, we have to be careful about calibrating the thresholds about false positives and false negatives. And there is an existing implementation where Google Gemini has provided an example for this as well. And the final method is monitoring, which is very essential for tracking all these, any insertion or retrieval from vector databases, and it is essential for compliance and alerting when they detect any anomalies. So I've just summarized everything that I said. Another defense strategy, an advanced defense strategy for embedding inversion is inserting noise, where when we are creating the embeddings for text, right? It is common to add a little more noise sampled from maybe like Gaussian distribution or something like that. So that when it is retrieved, when attackers retrieve these models, they are not able to identify or formulate an embedding with that. Differential privacy is another technique which guarantees that not a single embedding is being retrieved frequently. I think other things are common covered by me, and these are all this can be a checklist for software engineers for AI applications, especially access control, data validation, anomaly detection, that can be optional. Logging and monitoring, source authentication, encryption, and when they are testing, red teaming, simulate all the existing attacks so that our application or LLMs don't do the same thing. And yep, these are examples of available implementations. There are a lot of libraries and open source snippets that are available that we can use to adopt these strategies. And the things that I talked about are also mentioned in OWASP defense. And I've also provided a QR code if anyone wanted to access my slides.
Thank you, Rajesh. We have,
I'm sorry for the long. If you guys have any questions.
yes, we have
feel-
5 minutes for questions until we have to get ready for the next speaker.
Yep.
How do you ensure the model that you are actually trying to classify an attack versus not an attack, or trying to predict or anomaly detection? How do you ensure that itself is not compromised as a model, like kind of biased towards some input versus the other?
So, so what happens in the vector poisoning, right? So for example, one of the examples that I gave is they just ingested a few examples of malicious embeddings in millions of records, right? So those malicious embeddings, it's very common if our system is vulnerable, that they are like that embedding gets fetched more frequently. So sometimes it might be not common. So for example, if it is, so if we have an access, if we have a metadata saying that US, if all embeddings around US are retrieved, then it's fine. But if, so this is one technique. So for example, where, it's not related to any metadata, but we found that this is a very common embedding that's been retrieved more frequently than normal. So, our anomaly systems should be able to identify any retrieval outside the expectation. So it depends on the business case. So we train the anomaly systems based on the use case, where if it goes outside what is expected, I know, I think a lot of the engineering teams doesn't focus around that area, but it's especially important for data teams with sensitive information, right? If they have a very large scale use case involving user data, I think that is one thing to explore.
Okay, thank you, Rajesh.
Thank you.